All right, now, here's the deal. You got to, and everything we're doing right now, you have to keep in mind everything we already did with valence electrons, with ion formation. We'll go over ions more, because I know you're probably not totally sure on that, but you have to keep all of that in mind. Okay? So, let's look at these two things. Here's carbon. Its Lewis structure is this, because it has 4 valence electrons, correct? You can look on your periodic table and hopefully identify that carbon has 4 valence electrons. You have to be able to do that. You have to be able to write out that the structure goes right there. Okay? There's carbon, 4 valence electrons, just sort of review. Now, hydrogen. You remember how I told you the dot should always be on top first? I'll be honest, it doesn't really make a difference where you put the dot. All right? If you marked it wrong on your test, I didn't change it. Or I didn't mark it wrong. So I'm going to put the dot over here for hydrogen. It doesn't make a difference which one it's on, truthfully. Now, hydrogen has 1 valence electron, correct? It's right there, 1. Okay. Covalent bonding involves, you might want to write this down, it was on there, but it's a sharing of electrons, and that means electron. Now, the big thing here that you have to be aware of is that everything wants a filled outer shell. That's what I've been telling you, right? You remember, everything wants a filled valence shell, correct? So, what is a filled valence shell? How many electrons? 8. Good. So everything wants 8. There's one exception to that, only one. And it is hydrogen. Look at hydrogen, it's 1s, right? Hydrogen is in the 1s sublevel. So, how many electrons can go in the 1s sublevel? 2. So, the maximum that hydrogen wants is 2. Everything else wants 8. So carbon wants 8. Hydrogen wants 2. It still wants to be filled up. Are either one of those at their desired spot? No. So here's what's going to happen. Chemical bonding. The reason chemical bonding occurs. You can notice we have an open spot here, 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 and here, and an open spot there. Now let's imagine that we had 3 more hydrogens sitting around here. I see a way right now where each hydrogen can have 2 electrons and the carbon can have 8. Do you guys see that? Maybe you do, maybe you don't yet. That's fine. This is quite advanced right now, truthfully, for what we're doing. So yeah, what you're going to do now, this hydrogen is going to share its electron with carbon. It's going to share, share, it's going to share. So you'll rewrite this like this. Now, carbon has 8, and each hydrogen has 2. And don't worry, if this part's kind of getting out there, this is what we're going to talk about, truthfully, in a week or two. You'll be doing this yourself in probably a week and a half. But for right now, you notice carbon, does it have 8 electrons around it? Yes. Does hydrogen each have 2? Yes. So now everything's happy. I kind of say, oh, look, carbon's happy now. Look at that. Isn't that cute?
How did you get the other ones like the hydrogens?
Now, what?
How did you get like 3 hydrogens?
Oh, I just
rather than 1?
where those all come from, they just kind of appeared right now. Because the way it works, you have trillions of hydrogen atoms and carbon atoms, and they all sort of bond together like this. Don't worry about where those came from. All we care about is the way the electrons were arranged right now. What? No, that's the thing. Not yet. Hang on, you're getting ahead. So everything's happy. Carbon's happy. Hydrogen's happy. That's covalent bonding. It's a sharing of electrons. You might even want to add to get a filled valence shell. That's very important, actually. That's why everything does this. Now, that's a covalent bond. You would write it CH4, which again we'll get into later. Anybody know what that is off the top of their head?
Methane.
That's methane, yes.
Wait, what?
That's methane, CH4. Let me show you some more covalent compounds. PO4, NO4, HCl. Yeah. So, yep. Based on these, look at these covalent compounds I just wrote out down there. What is one thing you see in common with every element in all those compounds? There's one thing they all have in common.
There's always 4 of the second level.
Not always.
Oh wait.
This is kind of tough for you to figure out.
They all have 8. There's always 1 gas.
You're getting closer.
Two gases in there. 2 atoms.
Capital letters, yeah. They're usually single, but I mean, this one isn't.
Is it HCl?
Because C and then L. Think about what Will said. He said there's at least one gas.
There's 2 elements.
That's kind of right. Not always a noble gas, no. Look at the periodic table. Where are all of them? Where are they all?
On the right.
What?
On the right.
They're non-metals. On the right. So it's not always a gas. They're not all gases. But they're non-metals. So a covalent bond, and this is also very important, is a non-metal to a non-metal. I will be giving you questions. I'll be honest. These are going to be the easy questions on the test or on a quiz or something. And I'm just going to say, look at NO4. Well, let's say look at NO3. That's kind of more realistically a compound. I'm going to say, is that an ionic or covalent bond? And all you're going to do is say, well, let's find nitrogen on the periodic table. Let's find oxygen. Are they both nonmetals? Yes, so it's a covalent bond. Pardon? Which one, Barada?
The 4 one, you can't get it because it's not, it doesn't equal out.
Yeah, that one, that I kind of goofed up. It should have been, I was going to write NO3. So, covalent is non-metal to non-metal.